Sorry. That's good. Hello everyone. So today we're gonna introduce.
That's fine. You talk first.
Yeah.
You talk the first half and then start the second half. So.
Okay.
Yeah. So today, Jerry and I will talk about what we are doing at PSE. So right now we're working on a project called NPC Stats. Yeah. So Jerry and I and another teammate are working on this project. Yeah. So let's start. Yeah. So NPC Stats is a framework that allows users to perform statistical computation across different or multiple data providers. So we want to guarantee the privacy preserving, which means that data providers will not leak their data to others, and we want to guarantee verifiability as well, so that user can be convinced that the result is correct. So in this case, user can query like, what is the median? What is the mean of the medians of your database? So it's 2, 6, and average. So return 4. Yeah. So we're using MPC to do that, as our project name suggested, and specifically we're using a framework called MP-Speed, and it's because that we can define arbitrary computation with their Python DSL, and they support like many different MPC protocols, ranging from different trust model like malicious, malicious, like semi-honest, and dishonest majority, and honest majority, etc. So we can easily benchmark through different MPC protocols with the same program. So you can define something like this, like it's basically reading input from party 0, reading input from party 1, and perform some like addition, multiplication, and then reveal the result. So yeah, it's basically Python, like DSL. And our library, so we have implemented some necessary statistical operations in MP-Speed. So we implemented 12 statistic operations, and also some join, like table join, and concat between different array or metrics, and filtering. So we can filter some data that we're not interested in. So yeah. So right now you can do something like this: read data and do median, got the mean. And we also integrated with the TOS notary, so that the MPC inputs are authenticated from the web pages. So originally in MPC, you couldn't guarantee the other parties are giving the correct input. So it's a problem. So different parties can just input like garbage value, and you get garbage output. So with TOS notary integrated, we can make sure that the inputs come from like some website. For example, this website has a balance like 1, 2, 3, and we use TOS notary to notarize and get a commitment. So this is a hash from something and the private input. And what we did is that we also compute this commitment inside the NPC and reveal it. So people can verify this TOS notary proof and check the commitment here equal to the commitment from MPC. If they are equal, that means that the input is the same from the website. And we also did benchmarking through the protocols provided by MPC. And in our use case, we need malicious security, so parties couldn't deviate from the protocol. And so we found a protocol named malicious replicated ring, which is protocol from MPC, which is feasible for us, but it requires honest majority, but it's still it is still enough for us. So we have 3 parties, and we used D3 median, so 2-3 CPU 4 gigabyte RAM, and with different regions to compute the average of like 10,000 fixed points. It takes like 11 seconds, and to compute the TLS notary commitment, it takes like 60 seconds, which is not good enough, but still feasible. So we also tested the same region. So all of the parties are in Asia, and it became better, a lot better. So like it's roughly just 1 second. So it's a lot better. Yeah, and for the rest, Jared will talk about this.
So thanks so much, Kevin, for the introduction, the project, right, MPC stack. So yeah, let's take a look more at how the core of it is actually is, right? Because I think you guys know about MPC, multi-party computation, allow us to have people with secret data to compute something together and get the shared result, right, without leaking that data. And actually the magic of how this happens is the intuitive approach for MPC, which means that we require everyone, right, data providers and data consumers. So data provider is the one that provides private data, right, and the data consumer is the one that query the statistical computation for this shared data. So actually the magic of MPC happens because they are all computation parties, which means that these guys need to be involved in the process of computing the MPC itself, which means of what? So let's look at the diagram, right? So basically we have data provider, each have their own data source, right? And then this is data consumer, they want to get, let's say, I want some knowledge of a mean of you guys' data or something like that, right? But this requires them to be computation parties, meaning that they need to be online all the time at the same time. So the pros is that like, because everyone is a computation parties, we can be sure, right, that like, if you guys run the wrong program, it wouldn't work, right? Because by being the computation parties, they can be sure that, let's say, if it's malicious, right? Like, just trust one. I'm pretty sure I'll trust myself. I'm not gonna do something weird. So I can be sure that these data consumers can be convinced that the computation is done correctly. The bad thing is, again, they need to be online all the time. And this means oh, is this fine, right? If there's just 2 data providers, 3 providers, and then 1 data consumer, but then the reality, right? Imagine the statistical function. You need to ask data from hundreds, not even thousands people, right? And come on, you cannot require thousands of people to be online at the same time. So that's why we use another approach called client interface. So what it essentially is basically we decouple between data provider, data consumers, and computation parties. So we don't need anymore that anyone that want to do MPC need to be computation parties. Instead, they can be only data provider, they can be only data consumers, and they can be another party that is computation party. Just to be clear again, right? So let's look at this guy. This guy are data provider, but now they don't want to be online all the time, right? Because it doesn't make sense, right? Like let's say I want some data of thousands of people. It doesn't make sense for them to be online all the time, right? So they just share input data to parties. So there's another thing called computation parties, which are separate from these guys, that will get the input here. And this guy is actually the only one that are online all the time to compute this result, right? So we kind of delegate the security to this guy compute, and then another guy called data consumer will just log in and boom, I get back. So if you see, there's separate things, right? Like this guy on the data providing phase can be just log in, provide data, and then log out. And this guy do the same thing, log in, log out, log in, log out. The only thing that is required to be like online all the time is basically the party itself, which again we can delegate to trusted party, we can delegate to like 3 trusted party different. We don't require every like thousands of these guys to be online all the time and need to join the competition parties. So that's what makes it beautiful, right? Like data providers and consumers only need to interact with the parties and then can go offline. So it's more practical, scalable when you really want to onboard like private data into use case. The bad thing is that again, because this guy never inside the computation party itself, right? They can have a problem because they need to come and trust like, yeah, if you use malicious setting, at least one of this party is honest, right? Okay. They worst case, right? They don't know this guy just like, oh, they just like cheat together and you have no way to know it because you're not in the trust, like this computation party yourself. But again, if you kind of like make sure that like these computation parties are selected carefully to make sure that they don't really collude, I think this one can be passed away. And yeah, no verifiability of what computation is performed is the same problem, right? Because you are not in the inside circle itself. So maybe if they cheat everyone here is bad guy, they can collude together, but again, it comes back to the trusted assumption that if we think that we carefully craft the computation parties to again have at least one people or honest majority, depends on the setup, right? Like you can help like avoid this, but again, this is the caveat there that we trade off to get the better UX so that people don't need to be online all the time and people can like be scalable in terms of the computation. Yeah, on the future, we have a thing called collaborative snarks, which basically we can create zero-knowledge proof to make sure that this computation is actually compute from the function that we want, right? Again, because we are the data provider, the data consumer doesn't involve in the computation part itself. We have no way to know if they really do that function, but with CKB proof we can do that. We can do FHE, so that again, the bad thing about MPC is that everyone needs to be online. We kind of avoid that using the client interface as explained, right? But in FHE, we don't really need to be online at all, right? We can just encrypt data, send it to a centralized server, and then yeah, they do that stuff. Okay, to make FHE become verifiability, that's another problem because you need to like try like how to prove that FHE like usually compute like correctly in the function that you want them, right? But again, this is all the future, and we see that like this kind of like need like programmable cryptography is just not one thing, right? You need like multiple things together. Maybe like you need MPC in the key sharing phase, maybe you need FHE in computation. We don't know, but we start to think about like how to make framework make more sense when you use like an MPC in the future, like how to scale to like more than just like a few people that require them to be online. How to again like make sure that we don't garbage in, garbage out by partnering with TLS Lottery, which they will have a talk soon, right? To make sure that this data actually come from a trusted source. And yeah. So application right now, briefly, we are thinking a lot of things. For example, there's some problem in government that like you cannot, like there's many legal entities, you cannot do data sharing together because it's regulation. With this, of course, it's quite intuitive, right? For MPC to do this data sharing, we can do verifiable salary survey, we can input like private data, and then they can kind of like make sure that like, oh, what's the actual mean of this without leaking. Interesting thing is about like data survey again, right? How to really like involve like people to get data out and use it for action, like policy planning, for research alliance, and I think like yeah, we think that there's a lot more interesting topics, including like if you think right that our future everything's gonna be data, like let's say I don't know, even our brain or anything, like everything's gonna be data at one point, and how to really make it make sense. So yeah, if you guys have any more thoughts on application, again, we are just general framework so that we allow any data, like a lot of data at the same time to be able to compute so that you don't need to share like each data, right? And last but not least, we are having demo coming up at DevCon soon. So the demo basically we can allow participants to share secretly their ETH balance on Binance. Yeah, so again, it's secretly, right? So and again, we need client interface, right? Because I cannot ask like let's say everyone in this room like oh, can you be online all the time at least like 4 p.m. now to share this, and yeah, right? So that's pretty much a use case. We need to make sure this works, like if it works already. So yeah, so we allow you guys to share your secretly. We don't know you, like but we can do like that. Stats in general of the ETH balance on Binance, and right now we have 3 parties, so we just share by different entities across countries. And yeah, so that's coming up soon during DevCon, and we actually want to involve people, so we will get NFT and a chance to win a lottery. So please scan this QR code to join our Telegram group. For more information, how to really do this is pretty simple. You can just run CLI to notarize your ETH like in Binance account, and that's all done. And you guys can see the statistic. But yeah, we will get updated soon. Really excited for this like coming 2 weeks. And yeah, Any feedback, anything on both this slide and the previous slide about the use case, please feel free to let us know. We think that MPC is pretty much overlooked a lot, and we think there's a lot of ways to make it into like scaling and to make it really practical. So yeah, again, thanks very much guys for coming here and can't wait to see you.
Handsome man!
Thanks. Yeah.
Yo, so I was wondering, I don't have Binance.
Oh.
Can I still join the live group?
What are you using? Coinbase.
Yeah.
You think we can finish it like somewhat? It's just a little bit different, but let's see. You can talk first and yeah. Thank you, Lance. Alright, yes, Oscar.
Maybe you mentioned it, but there was a difference in terms of latency, and it was like 100x to get 3 different regions.
Yes.
So I'm curious, like, how many round trips are we talking about? Like, could you tell us more about like how does latency impact the?
Okay, so actually I'm not sure about the exact number, but it's like 600 or 700, something like that.
Round trips.
Yeah.
Okay.
And I think rounds definitely a key factor of the latent. I mean, the key factor affecting the runtime.
And the rounds, is that something that is that like an active area of research? Like, have you seen it go down the number of rounds over the years? Is that like an open question, or is it like a hard limit that's always going to be this many rounds?
Sorry.
Like now it's like 60 rounds. Is that number going to go down, you think? Is it possible to have like
Less
10
rounds?
Yeah, less few rounds.
Yeah, I think that depends on the protocol we use.
Yeah.
And we already picked about the best performing protocol we had in MP speed. So I think it's possible to have less rounds, but we probably need other framework.
It's like a research area kind of.
Yeah, yeah.
So both on the language itself and on the algorithm itself as well. I mean, yeah, it's good.
Yeah, and yeah, it's also possible if we can optimize our circuit. So yeah, it's possible, but yeah, probably the key factor is the MPC protocol itself. Yeah.
And then also for your future moves about F18, I remember you mentioned having verifiability. I think Paddle Labs released, I don't know if it's like a library or just a research paper, but it's on zero knowledge F18. But to make a snark of that F18 computation, you could probably use that for verifiability.
You mean from
Paddle Labs?
Paddle Labs? Okay,
Yeah.
I see, yeah.
Mm-hmm.
Thank you for the suggestion. Yeah. We'll definitely check that out.
Who will act as the node tree for the TLS authorization?
For now, we will set up our own because actually we had some slight modification to the TLS notary server. Yeah, we changed the we changed the hash function of TLS notary, which doesn't affect the security, but in MP speeds, it will be a lot easier for us to implement that. So originally they used Blade 3 and we changed it to SHA-3. So it might not be compatible with the official notary server from TLS Notary, so we needed to run our own.
That's why did you change it?
SHA-3.
SHA-3.
You changed it to
From Blake 3.
From Blake 3 to SHA.
Yes, yes. Yeah, but I'm pretty sure it can be fixed. It's just like we have limited time to implement it. Yeah. Anything else? Or that's it?
Thank you guys.
Yeah, thank you guys.